What is matter? Anything that has mass and occupies space is called matter. It means that anything that has mass and also occupies space is what we call a matter. And now let's talk about the states of matter: solids, liquids, and gases. Solids. Solid is a state of matter in which molecules are very tightly packed without any intermolecular space, resulting in being harder and denser. Properties of solids: solids are hard, very less intermolecular space, do not flow and remain same until a force is applied. Solids are non-compressible. Liquids. Liquid is a state of matter in which molecules are packed more loose than solids, in which larger intermolecular space result in the being softer and easy to flow. Properties of liquids: liquids are soft, large intermolecular space, liquids flow. Liquids are hardly compressible. Let's talk about the gases. Gas is a state of matter in which molecules are very loose, with larger intermolecular space, and particles moving freely in any direction. Properties of gases: gases are softest, largest intermolecular space. Gases flow in any direction. Gases are highly compressible. Things to remember: anything that has mass and occupies space is called matter. Matter around us exists in three states: solids, liquids, and gases. Matter is made up of small particles. Gases have the largest intermolecular space. Solids have no compressibility. Gases are highly compressible. Liquids take the shape and container that they are placed in.
What is energy? Scientists define energy as the ability to do work. Modern civilization is possible because people have learned how to change energy from one form to another and then use it to do work. People use energy to walk and bicycle, to move cars along roads and boats through water, to cook food on stoves, to make ice in freezers, to light our homes and offices, to manufacture products, and to send astronauts in space. And there are many different forms of energy. It includes heat, light, motion, electrical, chemical, and gravitational. And these forms of energy can be grouped into two general types of energy for doing work. First is the potential or stored energy. Second is the kinetic or working energy. And then energy can be converted from one form to another. For example, the food of a person's eats contain chemical energy, and the person's body stores this energy until he or she uses it as kinetic energy during work or playtime. The stored chemical energy is called or natural gas, and the kinetic energy of water flowing in rivers can be converted to electrical energy, which in turn can be converted to light and heat energy. Energy cycle. The sun begins the process through organisms like plants and other photosynthetic producers. The higher organisms eat the lower organisms, break down their matter, and and rearrange the molecules to make their own matter. When any organisms die, the remains are broken down and put back into the cycles in organic molecule. The sun is the source of all of our planet's energy. Sunlight is absorbed and used by the producers to create matter from smaller matter. Energy from the sun is used to drive the process of photosynthesis, constantly renewing the energy lost to the environment as heat from life processes. The autotrophs, also known as the producers, include plants and mini bacteria, plant-like protists, and even some fungi. These organisms perform photosynthesis and create the basic organic matter from inorganic matter. In most cases, the energy from the sunlight is captured by chlorophyll. The use of nutrients allow autotrophs to produce matter from higher trophic levels. The producers break down some of the matter that be manufactured to produce energy. Matter cycle. Matter moves in a different way than how energy moves. Thus, unlike the one-way flow of energy, matter is recycled within and between ecosystems. Elements that pass through from one organism to other in closed loops is called biogeochemical cycles. These cycles involve biological process, geological process, and chemical process. Human activities also play a significant role in biogeochemical cycles. Matter that moves through the cycle is never destroyed or created, it is simply changed. Biological process consists of any and all activities performed by living organisms: breathing, burning, and eliminating waste products. Geological process includes volcanic eruptions, the formation and breakdown of rocks, and major movement of matter within and below the surface of the earth. Chemical and physical process includes the formation of clouds and precipitation, the flow of running water, and the action of lightning. Human activity. Activities carried out by humans that affect the cycle of matter on a global scale. This includes mining, burning of fossil fuels, the clearing of land for building and farming, and the burning of forests. This generic food chain shows how energy moves between organisms. Notice that no matter what dies, there is a path for the matter to get back into the food chain through the scavengers and decomposers. And this food wave does not show all of the organisms that it should, but it does demonstrate how organisms have more than one food source. The arrow shows the direction of matter and energy flow. Since the producers do not eat the scavengers and decomposers, the large arrow shows that the matter and energy from their level is simply transferred to the producer's level. The arrows on the right shows that each level eventually dies, and the scavengers and decomposers break them down.